This problem is asking us to solve the following equation. Negative x minus 3 halves equals 5 halves x minus 1/5. Okay, so my tip for doing these is to always isolate or to figure out what the least common denominator of all the fractions are, multiply through on both sides by that LCD, and then see what you have left over. What will happen is that you will only have integer coefficients and integers, which is a lot easier to work with. So of course our denominators this time are 2 and 5, and the least common denominator for 2 and 5 is 10. So I'm going to take this entire equation and multiply through by 10 on both sides. So I'm just going to put parentheses around the entire thing, and then I'm going to draw in some arrows so I can guide this here. I'm going to go there, and then there, and then there, and then there. Okay, so if I distribute through now, 10 times negative x is negative 10x. 10 times negative 3 halves would be, well, let's see, 10 divided by 2 is 5, multiplied by 3 is 15. So this would be a minus 15. Multiplying against the 5 halves, 10 divided by 2 is 5. 5 times 5 is 25. So there's a 25x. And then in the last spot, 10 divided by 5 is just 2. Times 1 is 2. So there we go with that spot. Okay, so in the next line now, we're going to collect like terms. So in this instance, I'm going to subtract 25x from both sides, so that way I'm collecting all my x's on the left, and I'm going to simultaneously add the 15 to both sides, so I'm collecting my constants. Okay? So what would be remaining after that stage? Well, nice cancellation here and here. Negative 10 minus 25 is negative 35x. And on the right-hand side, negative 2 plus 15 is positive 13. So now, one last step to isolate the x would be to divide both sides by negative 35. And after we divide by negative 35, looks like on the left-hand side with cancellation, we'll just have x. And then on the right-hand side, we have a positive divided by a negative, so that'll be a negative number. And this number happens to be 13 over 35. So not the best number I've ever seen, but the solution to the problem nonetheless.